In this presentation, I'm going to talk about some common and basic math symbols that you will see not just in math, but also whenever you are operating with numbers. This is the Greek alphabet, and I highly recommend you memorize it. You're going to see the Greek alphabet throughout the rest of your life, and you're going to save yourself some time and heartache if you just put in the energy to memorize the Greek alphabet. First up is pi. This is how I like to write pi. And pi is the ratio of a circle's circumference to its diameter. A lot of people know the value of pi, but they don't know this definition of pi here. And it's pretty important because this reminds us that pi, which is the circumference divided by its diameter, is a constant number. It's a fixed number that will always be the same. Here are the first few hundreds or thousands of digits of pi, and it starts off with 3.14. Really, that's the important part. If you can get that down, you're fine. The most I've ever seen someone need to remember was 6, but the more the merrier. If we talk about pi, we have to talk about e. E, very simply put, is equal to half of pi. So here we have a graph of e to the x with its inverse, which is actually the natural logarithm of x. It's very interesting how this works out, but it goes a lot deeper than what this video was intended for. So if you'd like, you can pause and wonder at this phenomena. These are all roots. The square root has this imaginary 2 right here that you can't see. And we have a cubic root and also a quartic root. What we need to ask ourselves whenever we see a root is this question right here. What number do I have to multiply twice in the case of square roots, thrice for cubic roots, or 4 times for quartic roots to obtain the number that's inside of the operator? So remember, there's an imaginary 2 right here. And what we're asking is what number will multiply by itself twice to obtain 100? Well, the answer to that is 10, because 10 times 10 is 100, or 10 squared is 100. Here we have the cubic root of 1000, and what we're asking is what number multiplies by itself 3 times to obtain 1000? And the answer is, again, is 10, because 10 cubed is 1000. Here we're asking what number will multiply by itself 4 times to obtain 1? Well, the answer is 1, because no matter how many times we multiply 1, it'll always result in 1, even if this was a square or cubic root. So I'm going to ask you something. Does it make sense then why we don't have anything that looks like this, where this is a 1? This is delta. Delta means change. We just don't know how much that change is. When we're trying to find the rise over run, or better known as the slope, what we're really asking you is what changed happened in y, what changed happened vertically, and what change happened horizontally, or what change happened in x, and this results in the slope. So here is the imaginary number I, and no, I did not make that up. No kind of pun intended there or anything. Anyway, I is equal to the square root of -1. Let's talk about why we need this symbol and why that's important. So let's say that we have 4 times 4. Well, we know that that results in 16. But also, if we have -4 times -4, well, that also gives us 16. So if I'm asking you, what is the square root of 16? Well, there's 2 different answers. There is a positive answer and a negative answer, but they are both 4. However, if I ask you something like, what is the square root of -16? Well, this is a problem, because what I'm asking you is what 2 numbers will multiply together to get -16. Well, there are no 2 numbers that multiply to get -16, or really any negative number for that matter. So what we've done is we've factored out this negative 1 out of the -16, and so we have the square root of -1 times the square root of 16. Now we can handle this. we can say, okay, well that's going to be the square root of 16 is 4, and we write the numbers first, and then we'll write I. So the answer to that is 4I. Tee-hee. An interval is a domain of numbers that we have narrowed down, that we have felt were relevant to a given problem or situation. So for an example, if I would like to define how old someone can be or define someone's lifespan, I would not use any negative numbers because no one can be a negative age. And I also wouldn't use anything greater than 140 or 145 because I don't have any record of someone living that long. So therefore we have an interval. Our interval would be from 0, and I believe the oldest person lived to be about 134 maybe, so I'll say 135. So there are really three different types of intervals. One of them is a closed interval where we include the endpoints. Because all of the numbers in between here are defined in our equation, we have to have some kind of way of defining the endpoints as well. So if we write someone's lifespan like this, from 0 to 135 on a closed interval, what we're saying is that a person lives from exactly the time they are 0 to exactly the time they are 135. But we know that this isn't the case. If I write someone's lifespan this way, what I'm saying is that a person lives from about 0 to about 134 years old, 364 days, 23 hours, 59 minutes old. Okay, that's how long they live, but they don't actually reach 135, is what I would say. So since we know that a person can be 0 years old, then we need to do a new type of interval where we mix the two of them. So a person can be 0 years old by the intermediate value theorem, which says that, if we went from being non-existent to a first birthday, at some point in between we had to have been 0. So I think that's pretty fair. Now 135 is a little tricky because not everyone lives to 135, and not only that, but the oldest person in the world didn't live till 135. So therefore this is an open interval. You get really, really close to 135, but you don't actually reach it. So notice here we have infinity, and infinity is with an open interval. Okay, we can't have a closed interval for infinity. It doesn't make any sense. We never actually reach infinity. Remember, infinity is not a number. We cannot reach it. It's a concept of a number. So anytime you see infinity, it'll be on an open interval. And this right here, what this means is that all real numbers from negative infinity, from all the negative numbers, from all the positive numbers, is within our interval. Intervals can also be defined with less than and greater than signs, which I think is extremely obnoxious, but it is very often that we represent intervals this way. So please take a look and see how the closed intervals and the open intervals correspond with the inequalities. Undefined and does not exist are valid answers to a lot of problems that we have in mathematics. Undefined usually means that we got some number, but it doesn't really make any sense for the problem that we're given. Maybe we have an interval from 1 to 4, and we get an answer that's 10. Well, 10 is not within this interval, so 10 would be undefined. However, does not exist steps into another realm. Not only are we not getting an answer, are we not getting a number, but we don't have an answer period for the problem given. So here's a few things to look out for that might give you an undefined or does not exist. These right here are known as the indeterminate forms, and they are most likely to give you a does not exist answer more so than anything else. It goes beyond the realm of being undefined. Not only is it undefined, but algebra has broken and we have no idea how to solve these. Be very cautious of your intervals, what falls in and what falls out of your intervals. You cannot have a negative area, volume, or amount of space. It doesn't make sense. And remember this is the vertical line test, and this graph failed it miserably. Remember that the vertical line test is basically saying that for every input that we have exactly one output. Well, in this case, our input was 4, and we have one solution up here and also a solution down here. So that fails. Proportionality, a part or a whole of something that is somehow related to a part or a whole of something else. When something is inversely proportional, we still write this, but whatever it's inversely proportional to has a 1 in the numerator, and then whatever is proportional in the denominator. Pressure is inversely proportional to volume, meaning that as the pressure goes up, the volume will go down. And pressure is directly proportional to temperature. If the pressure goes down, then the temperature will also go down. The set membership symbol looks a lot like a C and an E had a child, but it means whatever is on the left is included with whatever is on the right. And when there's a slash through it, oh, well, you guessed it, whatever is on the left is not a member or is not included in whatever is on the right. So birds are a member of animals because birds are a set member of animals. Every bird is an animal. Meanwhile, birds are not included in the group of reptiles because birds are not a set member of reptiles. The inverse A looking symbol, or maybe it's a V with a line through it, denotes when all elements for an equation or situation are possibilities. It means for any, for all, for each. So this looks a lot more complicated than what it really is. But all this is saying is for all values of some number, and in this case the some number that we used is x, when that number is negative, or when that number is less than 0, it will not be included in a set of positive numbers, or numbers that are greater than 0. Okay, so in plain English, for those of you who still don't get it, if a number is negative, then it isn't positive. A complex number is simply when we mix imaginary numbers and real numbers together. So we have this real number 12, and then we have this imaginary number 5i, and somehow we're supposed to add them together. A set of real numbers, and I hate for this to sound so sarcastic, but a real number is anything that is not imaginary. A natural number are numbers that we use to count, so they are non-negative whole numbers, including 0. Integers are numbers on a counting line, anything that goes from negative infinity to positive infinity as a whole number. When we want to get specific, we use this plus right here, and what we're saying is only positive integers. And whenever we want to include 0, but we're still only using positive integers, we're using this asterisk here, saying only positive numbers that include 0. So this one's a lot more nice. The existential quantifier is a backwards E, and it means there is or there exists. There exists some function that will yield only positive numbers and 0. One of these could be the absolute value function that looks a lot like this. The uniqueness quantification meet the existential quantifier's cousin, which is exactly like it except it has an exclamation point at the end, which means there exists exactly one. So try to take a moment to decipher what this is saying. there exists exactly one x in a set of integers where 25 minus the x equals 20. Can you guess what that x is equal to? This is sigma, and sigma represents summation notation. Summation is the addition for a sequence of numbers. So let's say we have 1 plus 2 plus 3 plus 4 plus 5. Okay, this is our series of numbers, and then our summation of our sequence of numbers would be 15. We have a lot more going on with sigma now. On the bottom we have this n equals 1 stuff, and this is just telling us what our variable is and what it is we're going to start at. So this variable could be k, it could be I, it could be x, it could be any letter. And whatever it's equal to is the number that we're going to start at. We don't necessarily have to start at 1. We could have started at 0, we could have started at negative 16, we could have started at 1,000 if we wanted to. This is the format that we're going to be adding our numbers in. So there's always going to be a 1 in the numerator, and then in the denominator, this is the number that we're incrementing, so it's going to change. This number on top tells us what number we're going to stop at, and in this case it's 4. So let's begin with the summation. We have 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, and that results in 25 over 12. There are many, perhaps too many, approximation symbols. The most common way that I see it is just this bent sort of equal sign, but I also do see it quite often as this, and thirdly I will see it in this form. So I would say that the three most common ways you're going to see approximation are as follows. Approximation means about equal to, almost, approximately, or just about. We can't say that it's equal because it's not the same thing, but we can tell you how close it is with these approximation symbols. An inequality is an equal sign with a slash through it, meaning that it is not equal. Whatever's on the left is not equal to what's on the right. And here we have a relationship between all of them, where pi rounds to 3.14, pi is just about 3, pi is approximately 22 over 7, pi is exactly equal to or the same value as 2 times e, a roundabout of pi is 3.14159265, pi equates to the circumference of a circle by its diameter, and pi is not at all equal to infinity. Here are a few more inequalities. Inequalities are read from left to right. From there it's just a matter of remembering what each of them mean, since unfortunately you don't have the words below them to help you. So we have to find a way to remember them, and one common way is to think of the open space as an alligator's mouth, and the alligator is very hungry and is going to eat the bigger number. So whichever way the alligator is facing, in this case his mouth is facing this way, he's going to eat the bigger number, and the bigger number out of, let's say 0 and 12 is 12. Another common way would be to make this into an arrow, where the arrow points to the smaller number. So if I have 3 over here, and then I would have 14 over here, since 3 is the smaller number. This less than or equal to and this greater than or equal to both have the same concept, except now you have this or, where it's very possible that they are equal to each other. But in any case, this is still an alligator, and this is still an arrow. Piecewise functions use inequalities to define where they exist. Here is where they are defined, and here is the equation. So what we're saying is if x is less than or equal to negative 2, let's find negative 2 here, then we're going to use this. And this line, actually ends up looking like this. And note that at the end of this line, it is in fact bubbled in. And that's because of this equals right here. It's this less than or equal to. Next we have if x is in between -2 and 2, we're going to use the equation 0. So the equation 0 is just a straight line on the origin. And at -2 we have an open circle, and at +2 we have an open circle, because it doesn't say anything about x at 2 or at -2, it just defines all of the x in between. And lastly, we have x greater than 2. If x is greater than 2, then we're going to use this equation here, x squared plus 1. And the equation x squared plus 1 from 2 on up looks like this. And again, we have an open circle because it doesn't define anything at 2. When we have two less than symbols stuck together or two greater than symbols stuck together, it means much less than or much greater than, respectively. A factorial is very similar to summation, except instead of adding the numbers, we multiply the numbers. We start with 1 and we add 1 up to whatever the number of the factorial is. So for an example, factorial 4, we have 1 times 2 times 3 times 4, which I believe gives us 24. Modulus, and modulus actually is abbreviated with this MOD. This actually is the symbol for modulus. Modulus is the number that remains once division is performed. Let's look at this example right here, 44 modulo 5 equaling 4. So let's take 44 and let's divide it by 5. So 5 will go into 44, let's see, 9 times 5 is 45, so that doesn't quite do it. But if we take 8, we can say 8 times 5 is 40, and 44 minus 40 leaves us with 4. Now instead of doing, adding the decimal and carrying down this 0 and continuing from there, instead we just stop and we say remainder 4. Now remember, this remainder though is what we're trying to find, and this remainder in this case is modulus, is our modulus, and that is equal to 4. So 44 modulo 5 is in fact equal to 4. A caret is used for exponential equations. All it's saying is the number on the left is being raised to the power of the number on the right. So 4 caret 4 is equal to 4 to the 4th. It's very redundant to write this on your paper. We just use this for the digital world because, writing this superscript right here gets really tricky and very technical. So instead we just get lazy and we use a caret. A norm looks a lot like the absolute value symbol, except instead of just being two single outside lines, it's two double outside lines. A norm rounds any number to the nearest integer. So as we can see, all of these are, this isn't an integer, nor is this or this, and when we round it to the nearest integer or the nearest whole number, this is our result. The absolute value. There's two different ways to think of the absolute value. The first way is to think of whatever is inside is going to become positive, but a more accurate way to evaluate absolute value is to know that this is the distance some number is from 0. So for an example, if we have the number 55.5 and we want to find the absolute value, well, the distance that is from 0 is 55.5 units, whatever those units may be. Now if we're finding the absolute value of negative 55.5, well, the absolute value of that, or the distance that is from 0, is also 55.5. Infinity's symbol looks like a sideways 8, and it is not a number, it's a concept of a number. A concept of a number that is endless, limitless, never-ending, goes on forever, and boundless. So here we have the equation 1 over x, and you should know right off the bat that this x cannot equal 0, or else the world will explode. Okay, but we can get infinitely close to 0, and technically, because there are infinitely many numbers between 0 and 1, or 0 and any two numbers, this graph will go on forever and ever without touching 0. It goes on to infinity. These three dots right here mean therefore, and they work very well in geometry and in philosophy. Whenever you're writing, you've made so many good points, so many facts, and then towards the end you'll say, therefore, blah 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 blah. This is my point all along. A equals B, B equals C, therefore C must equal A. Guys, thanks a lot for watching this video. I hope that it helped you and you learned something new. Please leave suggestions in the comments below. Tell me what major symbols I missed, and I will most likely add a section for it. Or you can leave suggestions for my